Let's begin. Today's July 14th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses 5 criteria cards and it's 5 verification cards. Let's go to turingmachine.info for the details. So in today's puzzle, we're using the following 5 criteria cards. Criteria card 2, 7, 9, 19, and 21. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. And on the bottom row, we've got criteria card D, and finally criteria card E. Criteria card A looks at our first digit, the triangle digit, and the Turing machine will let us know how to compare it with the number 3. So should the triangle value be less than 3, should it be equal to 3, or should it be greater than 3? Criteria card B looks at our last digit, the circle digit, and the Turing machine will let us know whether its value is an even digit or an odd digit. Criteria card C, the Turing machine will look at the 3-digit solution and will let us know how many of those digits should be 3. Should there be no 3s, a single 3, perhaps 2, maybe even all 3 should be 3. Criteria card D will look at our first 2 digits, triangle and square, add them up and compare it to the number 6. So should the sum be less than 6, should the sum be equal to 6, or should the sum be greater than 6? And finally, criteria card E, again, will look at our 3-digit solution and will let us know a little bit about its structure. Specifically, could there be a pair in the solution, as in the example 131, or could there be no pair, which could have 2 different scenarios where either all digits are different, as in the example 134, or all digits are the same, as in the example 222. Remember, the objective of today's puzzle is to find that one unique 3-digit solution that abides by all 5 criteria cards that we just described. And we're going to begin with an initial proposal of 314. So the first thing I want to do is I want to test criteria card B. I want to know if that last digit, circle digit, is an even or an odd. So let's go test B. Okay, so the Turing machine responds that it does not approve of what I have. I did choose an even 4. Since the Turing machine does not approve of that, it's letting me know that circle is actually an odd digit. So let me go ahead and type that up in section B. Circle is an odd digit. Okay, and because of course it is odd, I can actually cross out the 2 evens. So I'll cross out 2 and 4. Okay, so the next thing I'd like to find out is I want to know a little bit about the solution structure. So let me go ahead and test criteria card E. Okay, so it does approve of my proposal. If you look at 314, they are all distinct. There is no pair. So that's what the Turing machine is telling me with its approval, that yes, the solution should have no pairs. So let's go ahead and type that up in section E. And because there are no pairs, that means that all digits are distinct. Okay, so let's see what else. Let's go ahead and test criteria card D and see if we can figure out something about the triangle and square digits. So let's test D. Okay, so it does approve of my proposal. So the first 2 digits I have are 3 and 1. Their sum is 4. And since the Turing machine approves of that, that means that the sum of the first 2 digits is actually less than 6. So let's go ahead and type that up in section D. That triangle plus square should be less than 6. And so with that, with that, we can actually find out a little bit about what triangle and square could be. Since their sum has to be less than 6, neither triangle nor square can be a 5, because at a minimum, if you add 5 with, say, 1, you already have 6 or greater. So that means that neither triangle nor square can be 5s. So that's sort of interesting in that we do have a last 5 in circle, which, you know, could add to the all distinct values. Well, that does it for this round. We've already done our 3 Turing tests, and so now we're going into the phase where we'll discuss how to construct a good second round proposal. So the things that we have not tested are A, figuring out what triangle could be. Again, less than 3, equal to 3, or greater than 3, as well as how many 3s there are. So it is wide open. We have all of them available, and that does it. So it comes down to those 2 criteria cards. How interesting. So again, because they are distinct, you know, we do have a wide array of possibilities. They could all be odd, technically, but somehow, let's see, somehow, obviously, we're going to have to force circle to be, you know, one of those odds. So it could be that in the sum, we could have something like maybe something greater than 3, which would make it 4, which would force square to be a 1, and then there could be a single 3. That's as best a guess that I can come up with in order to, again, force all these values. Obviously, criteria card A will tell us what A is, and, you know, thinking it in terms of extremes, what could you limit triangle and square to be so that it still has a sum that's less than 6, but sort of force the issue on determining what the values are? And I just went to the extreme. Largest triangle, obviously the smallest square allowed, and then there'd be a 3. So let's go ahead and test that out. 4, 1, 3. Okay, so let's see. If I can figure out criteria card A, if it is indeed greater than 3, that definitively forces square to be 1. Yeah, let's just go ahead and test A. Okay, yes indeed. So that means that, yeah, the only allowed value so far for triangle being greater than 3 is actually 4. So let me go ahead and type that up in section A. That triangle is indeed greater than 3. And so what I'll do is I'll just move this over to the 1, so that way I won't have to do too much adjusting. I'll just cross out 2, 3, and then 5 again. Okay, and of course this does mean that square is 1, as I sort of, you know, calculated. And so again, I'll cross out everything else. And so that leaves us with, you know, several possibilities: 4, 1, 1, 3, 5. But of course, you know, if there were no 3, then which one would it be, 1 or 5? So I think it's safe to say that we can deduce that there is a single 3. Okay, and so again, we'll just say that it won't be 1, and it can't be 5, because otherwise 1 and 5 would give us what I call ambiguous solutions. So let's type out our answer of 413. And just a real quick check. Yes, the first digit is greater than 3. The last digit is odd. We're deducing that there is an odd. And the sum of the first two is less than 6. And there are no pairs. They're all distinct. Well, it looks great. So let's actually go verify on turingmachine.info of our solution of 413. No, oh wow, it is not 413. Where did I make my mistake? It has to be 41. So what could have... Oh no, I see my mistake. Well, no, both 1, 3, and 5 were still available. Oh, I see, because it's 4-1, it automatically couldn't be a 1. So I jumped the gun. It should be 415, and so I'll deduce that there is no. Here, let me do this so that I preserve my mistake. Well, I'll just type it this way. There is no single 3. Okay, which would mean that, again, because of the 1, I neglected to come back and remove the 1, therefore making it a 50-50, which allowed it to be that there isn't. So my mistake on calling 1 and 5 ambiguous, I had not crossed out the 1. That was my mistake. So now let's go back and verify 415. Now I'm not sure how I'm going to categorize this as far as the Turing machine goes, because I guess technically I should have actually, yeah, there we go. We got the correct answer now, 415. So technically, if you go back, at that point, yes, I would have definitely made tested criteria card C, but the way the game rules play, I've actually lost because I got the wrong answer. So let's just see what the Turing machine has. So I will just type in B, D, E, and then A. So B, D, E, B was wrong, D, E, and then A. Okay, and of course I would have tested C. So yes, had I realized that the 1 should have been crossed out because of the no pairs, I would have realized that there 3 and 5 were the only remaining circle values, and at that point I would have been forced to test C to figure out is it there or not. So the very important gameplay sort of rule that go back and verify that you've crossed out everything at every step. That was my fault. Well, that will have to be a learning experience. So other than that, if you noticed anything else, please do add it to the comments. And if you like the video, please give it a thumbs up. Otherwise, please hit subscribe so that you don't miss out on any future videos. Well, until next time, have a great one.